So, hello everyone. Welcome to my YouTube channel that is on plus one, plus two, nine, and math concepts. So, we'll try to learn each and every concept in a very grateful and a learning way. Okay, we'll try to learn these concepts as some kind of puzzles, some games, so that it would be very much easy for you guys to understand each and every concept. So, first module will cover sets, relation, and functions. So in today's lecture, we are going to discuss the concepts of sets. Okay, so it's very easy. Okay, so let me define the definition of sets first. So what do you think? What is the meaning of sets? So the definition of sets is a well-defined collection of objects is called a set. So definition is very much easy to understand. A well-defined collection means a collection of objects is called a set. But here is a very important meaning of well-defined. Let me try to elaborate the meaning of well-defined here. Okay, let's say there are two persons. One is person A, another is person B. So I asked the one question. That is, what are your favorite characters? So A told me some names. Let me represent that collection of that names as a set A. So he said Kohli. He said Rohit Sharma. He said, let's say, Chris Gale. And I asked the same question to person B, and he named me, um, let's say, Rahul Dravid. Let's say Sachin Tendulkar, Kapil Dev. So if you see, the names of characters are objects, okay? And in both sets, I just collect the objects. So it means they are set, okay? But do you think they both are same? So answer is no. So they both are not same. So it means A and B are not sets. Why I'm saying this? So here the concept of well-defined came into picture. And what is that concept? Basically, well-defined means which has the same definition of everybody. Okay, the same definition to everyone. Okay, so but in this example, if we see, definition is something different because it is it's basically it's about, this question is about preferences. Okay, so A have some other preferences, B have some other preferences, so we can't say that both are well defined. But if I ask the question like this, what are natural numbers, or list the natural numbers, then what should A write? A will say, okay, I know that 1, 2, 3, 4, 5, up to so. And if I ask the same question to B person, it will also write this thing. Order might be different, but order doesn't matter in the sets. Okay. So, but this, the one thing is that they both list the same elements. So collection of objects is there, collection of objects, numbers of the objects, and both have the same meaning for them. So that means this is now well defined. So that's why well defined is a very important word in the definition of sets. Because if the set do not, if set is not well defined, or if a collection of objects is not well defined, we can't say that it's a set. That's very simple definition. Okay. I hope it's clear to everyone. Okay, so now we'll see representation of sets. So there are two kinds of representation. Number one is roster form, or other is set builder form. So let's see roster form. Roster form means that if I'll say set of all natural numbers lying between 1 to 10, you will say, okay, sir, I will list down the numbers 1, 2, 3. That's okay. This is my roster form. Whenever we are listing the elements into the set, okay, it means we are talking about a roster form. Now, what is a set builder form? Set builder form means a small notation. Like if I'll define this thing, A, we will always use capital letters to denote the sets and small letters to denote the elements. So A is equals to X, where X represents some elements in A, and those X belong. This is a symbol of belongs, means this X belongs to what? Natural numbers. This is a symbol of natural numbers, such that X should lie between 1 to 10. So if I write this, then also you are convinced it's nothing, just set of natural numbers 1 to 10. If I write this, then also you are convinced it's nothing. It is just the elements which are natural numbers which are lying between 1 to 10. But why there are two representations? जब एक से काम चल रहा है तो हम इस पे क्यों फोकस करें? इसके लिए इतना सिंबल्स आ जाएंगे, belong आ जाएगा, नई नई चीजें आ जाएंगी, वो सीखनी पड़ेंगी. Now you just see why. If you see, whenever any mathematician writes a book, okay, the printing or the publishing cost of book represents the number of the price depends on the number of letters or the digits that you use to write a book. Okay, if I have to write down set of all natural numbers lying between 1 to 100, are you going to list down number from 1 to 100? Then you think it printing cost will be higher. Okay, but similarly I can write down in a very short notation that x is, its element will be represented by x, where x are nothing, just natural numbers, such that x lies between 1 to 100. So my printing cost will be little smaller because I made the whole concept in a very small notation. So printing cost has been reduced. So if my printing cost has been reduced, then in the market, when the book will be published, it will have a lesser cost, and more buyers will be more buyers will afford that. And if, and what I want, do I want that कि मेरी बुक कम लोग खरीदें या मेरी बुक ज्यादा लोग खरीदें? इट्स वेरी मच अंडरस्टूड. आई वांट कि मेरी बुक ज्यादा लोगों तक पहुंचे. सो उसके लिए मुझे प्रिंटिंग कॉस्ट उसकी कम रखनी पड़ेगी, सो दैट उसकी जो पब्लिशिंग कॉस्ट जब मार्केट में है तो उसका प्राइस कम रहे. सो दैट्स व्हाई set builder form is very much useful for us in writing whole the concepts. I hope I cleared this concept. Okay, so that's very easy. Now we'll do one or two examples. Okay, let me introduce some symbols for you. N represents set of, this is a Greek one, Greek letter, N along with some line, set of natural numbers. और ये क्या होते हैं? ये कुछ नहीं, 1 2 3 4 5 ये सारे numbers होते हैं. Let me use some bright color. Then we'll represent Z. Oh, color has not been changed. Just a minute, guys. So then I write down Z. Yes, I'm just having meeting. Then we print Z. Z is nothing. Set of integers. Integers like negative numbers as well and the positive numbers as well. Then we'll have a whole numbers. W is for set of whole numbers. Whole numbers is nothing. Just add zero in the natural numbers. Okay. So then we have a set of rational numbers. We will represent it by Q. So rational numbers are nothing which are of the form P by Q, where P and Q are nothing, some integers. Okay. Then we have irrational numbers. For irrational numbers, we can use IRR. There is no specific symbol for that. Irrational numbers means which are in the form of surds. Surds means which involves some under root. Okay. There are also other definitions for irrational number that we will cover it in a different lecture. Okay. So natural numbers, integers, whole numbers, rational. Then we have real numbers. Means set of all real numbers means in the decimals one. Integers, every number that exists in this earth is a real number. Okay. So these are some notations. So basically I can say that real numbers is nothing, rationals and irrationals. Just forget about this symbol right now because we will cover the sets union and all these things. For the time being, just familiar with the symbols. So I think we are clear with the representations. Let's do a very small example for that. They said write the set x such that x is a positive integer and whose square is less than 40 in roster form. Now from this example, you will learn more that what is the use of set builder form and roster form. Okay, let's try to write down the roster form. X is a positive integer, means we are not considering the negative ones and the zero one. So let's start from the one. Obviously, positive integer means we are talking about the natural numbers. So x is 1. 1 square is less than 40. Yes, so 1 can be part of a set. So if I took 2, 2 square is less than 40. Yes, so 2 can be part of this. 3 square, which is 9. 9 is less than 40. So 3 is a part of set. 4, 4 square, 16 is less than 40. So 4. 5, 5 square is less than 40. So 5. 6, 6 square is less than 40. That is 36. Obviously less than 5, less than 40. Then 7, 7 square 40. No, that's greater than now 40. If I took 7, 7 square is 49 and 49 is greater than 40. So it means these are the numbers. Now you see, in a book, let's say we are not interested in set builder form. In a book, I want to specify some set and I will just list down these elements. Will you be able to understand what does it mean? Or what I want to convey? ये set क्या कह रहा है? तो आप बोलोगे सर ये set ये भी हो सकता है कि x such that x is natural number और x lies in 1 to 6. बट ऐसा तो नहीं है, पर मैं क्या सोच रहा हूँ? What I want to convey you this set, what this set is representing. If I write down in this way, you will immediately understand what I want to convey. X is a positive integer such that x square is less than less than 40. So you will immediately understand my intention. So that is the main use of set builder form. Because set builder form clearly expresses my ideas or what I want to convey you. So that's why many of the mathematicians or many of the maths books are written with the set builder form, not with the roster form, because roster form increases the printing cost, and also कहीं ना कहीं रोस्टर फॉर्म जस्ट वेट द इंफॉर्मेशन कि वो इंफॉर्मेशन जो हम देना चाहते हैं वो वेट हो जाती है, वो गायब हो जाती है. दैट्स व्हाई वी यूज अ सेट बिल्डर फॉर्म. सो दैट्स विद द रिप्रेजेंटेशन. I hope you guys will be able to understand this thing. Now let's do next thing, that is the types of sets. So the first type is empty set. That is my favorite set. Why? क्योंकि इसमें कुछ नहीं है. Okay, so you see, let's consider a set A such that x is a newborn child which is having age less than 0. Let's try to write down the roster form. क्या है इसके एलिमेंट्स? न्यूबॉर्न चाइल्ड जिसकी एज क्या हो? लेस देन 0. डू यू थिंक इट्स पॉसिबल? यू विल से सर अगर रजिस्टर फॉर्म में लिखेंगे तो यहाँ पे कुछ नहीं आएगा, तो इट वुड बी लाइक दिस. So I just made two curly braces with nothing in that. So it means it is an example of a empty set. So there are many ways to write down it. Second way is I'll just put 5. That also means that it's a empty set. There are many other names of empty set is like null set. We can say that is null set, void set, or empty set. These all are the names which will be used by the many books, but all have a same meaning. Is it okay? Okay. Similarly, let's do some more example. If I am having B such that X is a student presently studying in nursery and +2. Do you think it's possible? क्या कोई ऐसा स्टूडेंट है आपके नोन में जो नर्सरी में भी और +2 में भी? You will say sir no. It means it's an example of a empty set. So what is the definition? If I'll write down the definition of empty set, a set which does not contain any element is called the empty set, null set, or void set. So you can use any name. Okay. Okay. So let's now move towards the second type, that is finite set and infinite set. Now, what is the meaning of finite set? If any set contains finite number of elements, then we say that it's a finite set. For example, if I'll write down this set X such that X belongs to, I'm using this bar or this line to represent what are the conditions on S. X पे क्या क्या conditions हैं? So elements will be represented by small letter X. लेकिन X होना क्या चाहिए? X नेचुरल नंबर होना चाहिए और X 1 से लेके 6 तक लाई करना चाहिए. तो in that what would be my A? अगर मैं रोस्टर फॉर्म में लिखूं 1 2 3 4 5 6. So do you think this set contains finite number of elements? So answer is yes. So it's an example of a finite set. Very easy. Now let's see कि infinite set कब बोलते हैं. A such that elements X and X belongs to natural number. तो जरा लिखते हैं. First number 1 2 3 4 5 बस सर थक गया, यहीं पे छोड़ देते हैं। अप टू सोन, दिस इज द मीनिंग ऑफ अप टू सोन, चलता जाएगा ऐसे, बट इट विल नॉट टर्मिनेट, हम एंड नहीं कर सकते इसको। दिस इज एग्जांपल ऑफ अ इनफाइनाइट सेट। अब आपको पता है इनफाइनाइट सेट भी दो तरह के होते हैं। सर इनफाइनाइट सेट भी दो तरह के होते हैं, ये तो एक ही है कि जो इनफाइनाइट होंगे एलिमेंट्स, उनमें क्या दो तरह का होना। नाउ सी, देखो मैंने एक आपको सेट बोला, आपको रियल नंबर तो पता है ना, रियल नंबर क्या होते हैं। चलो एनी हाउ, और इसको इजी कर देंगे, रियल नंबर मतलब सारे नंबर्स है ना। तो देखो मैंने ऊपर एक लिखा है ए, एक्स एक्स लाइक नेचुरल नंबर है ना। अब एक सेट लिखते हैं ए एक्स सच दैट एक्स इज रियल नंबर, रियल नंबर मतलब डेसिमल वाले भी आ जाएंगे। एक्स लाइक जीरो, एक्स लाइक जीरो टू वन। देखो मैंने जीरो और वन को इंक्लूड नहीं किया, इट वुड बी नंबर्स विच आर इन बिटवीन जीरो एंड वन। तो अब आप जरा ध्यान से बताओ जरा मुझे सोच के, अब मैंने लिखना शुरू करना है ए को, पहले कौन सा नंबर लिखूं, जीरो के जस्ट बाद नंबर कौन सा आता है। आपको सर पॉइंट वन, लेट से आप ये कह रहे हो, इससे पहले तो ये भी आता है। अगर अब आप ये बोलोगे मैं बोलूंगा इससे पहले तो ये भी आता है। सो आपको नहीं पता आप कहाँ से स्टार्ट करो। सिमिलरली आपको एंड भी नहीं पता, वन से पहले कौन सा आता है, 0.9, नहीं मैं बोलूंगा नहीं ये आता है। आप बोलोगे ठीक है सर आप सही कह रहे हो ये आता है, मैं बोलूँ नहीं मैं भी गलत हूँ ये आता है। आप बोलोगे सर आप ये ठीक हो, मैं बोलूँ नहीं ये आता है। सो आर यू गेटिंग दिस थिंग। तो यहाँ पे क्या है, हमें पता ही नहीं है स्टार्ट कहाँ से करना है एंड कहाँ से करना है, बट स्टिल वी, बट हमें इतना पता है जीरो और वन के अंदर आएंगे इनफाइनाइट नंबर। सो दिस इज ऑल्सो एग्जाम्पल ऑफ इनफाइनाइट सेट। अब सर अगर इनफाइनाइट सेट दो तरह के हैं तो क्या नाम दें। ऐसे इनफाइनाइट सेट जिन पे आपको पता है पहले क्या आएगा, दूसरे पे क्या आएगा, तीसरे पे क्या आएगा, इनको बोलते हैं काउंटेबल इनफाइनाइट सेट। मैं काउंट कर सकता हूँ, मतलब काउंटिंग स्टार्ट कर दूंगा चाहे जाती रहेगी। यहाँ पे तो मैं काउंट ही नहीं कर सकता, तो इनको क्या बोलते हैं अनकाउंटेबल इनफाइनाइट सेट। ठीक है जी। सो वी नो नाउ व्हाट इज अ finite set and infinite set. Okay, so in this, now we will discuss the cardinality of a set. Cardinality of set means number of elements in a set. ये एक सेट के अंदर कितने एलिमेंट्स हैं, जैसे कि ये एग्जांपल है हमारे पास। अब इसकी कार्डिनलिटी को हमेशा हम ऐसे रिप्रेजेंट कर देते हैं, एन ऑफ ए मींस नंबर ऑफ एलिमेंट्स इन ए। कई बुक्स इसको ऐसे भी कर देती है डिनोट, कई बुक्स इसको ऐसे भी कर देती है, इट ऑल मीन सेम। सो इन दिस नंबर ऑफ एलिमेंट्स कितने हैं, 6, n of a is 6 or either j of a is 6, and this is known as a number is known as a cardinal number. Whenever somebody asks me कि इस सेट का कार्डिनल नंबर क्या है, तो हम बोलेंगे कि उस सेट में जितने एलिमेंट्स हैं उनको काउंट कर लो, लिख दो वो उसका कार्डिनल नंबर है। वेरी इजी। तो यहीं से भी हम फाइनाइट इनफाइनाइट बोल सकते हैं कि अगर तो सर कार्डिनल नंबर एक फाइनाइट नंबर है, देन इट इज अ finite set. Okay, and if is some infinite, then it is a infinite set. अब आपको होगा सर इनफाइनाइट में आपने दो टाइप बताई थी, तो उनमें क्या कार्डिनल नंबर में भी डिफरेंस होगा। एक क्या थी, काउंटेबल इनफाइनाइट, भी मैं कम से कम लिख पाऊंगा, एंड नहीं कर पाऊंगा, लिख तो पाऊंगा ना। अनकाउंटेबल इनफाइनाइट में तो मैं स्टार्ट ही नहीं कर पाऊंगा, मुझे नहीं पता पहले नंबर पे क्या आएगा। इन सेट्स की जो काउंटेबल इनफाइनाइट है, इनका जो कार्डिनल नंबर होता है ना, उसको हम लिखते हैं ऐसे, थोड़ा वियर्ड सा सिंबल है, एन को ऐसे लिख के पैर में 0, दैट इज नोन एज ए alpha naught. Obviously, these are not a part of your 10th plus 1, but sometimes it would be a question in a IIT JEE, तो आपको पता हो. Countably infinite में n of a is nothing, infinity. From cardinal number, we can also judge whether it's a countably infinite or uncountably infinite. I hope this is clear now, finite and infinite set. So next type is a equal sets. Okay, so when we say that two sets are equal, number one thing, when they have same cardinal number, सिर्फ कार्डिनल नंबर सेम होने से नहीं बोल सकते इक्वल सेट्स है, उनके एलिमेंट्स को भी सेम होना पड़ेगा. I'll show you. First I'll write down the definition. Two sets A and B are said to be equal if they have exactly the same elements and we can write A is equals to B. Otherwise, the sets are said to be unequal. So easy. अच्छा चलो, tell me whether these two sets are equal. देखो कार्डिनलिटी क्या है A की 4, कार्डिनलिटी क्या है B की 4, दोनों की कार्डिनलिटी सेम है, बट क्या ये एलिमेंट्स भी सेम है? तो आपको सर एलिमेंट्स तो सेम है, 1 इसके पास है, इसके पास भी है, ऑर्डर इज डिफरेंट, सेट में ऑर्डर तो डिफरेंट हो ही सकता है, दैट डजंट मैटर. 2 इसके पास भी है, 2 इसके पास भी है, 3 इसके पास भी है, 3 इसके पास भी है, 4 इसके पास है, 4 इसके पास है. सो बोथ हैव अ सेम एलिमेंट्स. सो इट मींस यस, वी से दैट A is equals to B. डेफिनेशन को ध्यान से पढ़ो, मैंने कहीं ये नहीं बोला कि एलिमेंट्स हैव टू बी इन अ सेम ऑर्डर. आई जस्ट टोल्ड यू दैट कि एलिमेंट्स जो हैं सेम होने चाहिए. अच्छा, व्हाट यू थिंक, क्या ये सेट इक्वल है? 1 इसके पास है, इसके पास भी 2 बार है, फिर क्या हुआ? सेट्स के अंदर कोई भी एलिमेंट कितनी बार मर्जी आ जाए, लिखा एक ही बार जाएगा. इफ वी आर नॉट टॉकिंग अबाउट मल्टी सेट्स, दैट्स अ डिफरेंट कांसेप्ट, बट उसको अभी हम छोड़ देते हैं. ठीक है, तो अल्टीमेटली एलिमेंट्स तो वही 1 2 3 1 2 3 है ना. सो यस, दे बोथ आर आल्सो इक्वल. सो इजी, इक्वल सेट्स आल्सो. Okay, so in this lecture I think we will cover this much. In the next lecture we'll start for subsets. Okay, these are just basic definitions which we can do. Thank you so much for viewing and listening this. We'll continue from here in the next lecture. Thank you.